Now, let's talk about MaxGauge Performance Analyzer. When you first access the MaxGauge Performance Analyzer, you will see this initial screen. In terms of the screen layout, you will see 6 main categories on the left side. And at the top, you can see the screen that corresponds to each of the categories. Firstly, let's look at SQL Analysis section. The SQL Analysis menu provides 4 screens that offers analysis in the perspective of SQL. The first one is Top Analysis, which lets you view top SQL statistics by specifying a particular date or a specific duration, such as the last 1 week or last 1 month. The time window function you see here is only based on SQL executions performed during the business hours. Generally, to perform a top SQL analysis during business hours, such as from 9 to 6, you can use the time window function. Over here, there is also Include and Exclude. If you wish to select a particular schema, for example, if you select SOE and Start, it only outputs the top information for the 2 schemas. And if you wish to exclude a particular schema, say the C's schema, select C's and change it to Exclude. Then, the top information excluding C's is outputted. Now, let's view top information for the last 1 month based on the 9 to 6 business hours excluding C's. As you can see, the top information excluding C's is outputted. For each of the items, you can view usage for critical information, such as Lipsett time, CPU time, and wait time. You can also view the actual performance statistics data. As you can see now, 6 tabs are provided here: Schema, Program, Module, Machine, OS User, and SQL. The 5 tabs from Schema to OS User have identical user interfaces. And as you can see at the bottom, you can view top N for each of the top schemas using 5 performance indicators: Lipsett time, CPU time, logical reads, physical reads, and executions. Also, by clicking a particular schema, you can view the history of SQL executions performed by the schema at the bottom, along with the Lipsett time and CPU time occupancy of the SQL. You can also view workload details of each SQL. Because it has become more important recently to analyze wait time of each class. MaxGauge allows you to view wait time of user I/O, application, concurrency, and cluster wait class. The SQL tab uses a slightly different user interface. By clicking in SQL, you can view detailed execution history, planning information, and binding information on SQL at the bottom. Top End offers a wide range of linked screens. By clicking the Long-Term Trend button at the top, you can view long-term daily trends for a selected schema. Click the button and you will see execution history of that schema for the last 1 month. This screen is showing you daily Lipsett time total of the schema. And at the bottom, in addition to the daily total elapsed time, you can also see average elapsed time, execution count, and average CPU time. Let's go back to Top End menu now. If you wish to know daily usage status of an individual SQL, you can right-click on it and use the functions provided. Because right-clicking is a commonly used method, let me show you some examples. Full SQL text provides the full text of SQL so that you can check the plan information and bind information. Also, long-term trend allows you to view daily execution history of a single SQL. By linking to long-term trend, you can view daily execution history of the selected SQL ID. You can view average elapsed time and average CPU time. The blue bar indicates the execution count. Bars of different colors are provided for different plan hashes. By distinguishing the bar color of each plan hash, it lets you easily identify timing of the plan change. Also, using the toggles, you can choose whether to view the data in the elapsed time perspective or CPU time perspective, or you can choose between the logical I/O perspective and the physical I/O perspective. Let's go back to Top End again. By right-clicking, you can access the Export Excel function and download the data as an Excel file. The multiple sort function lets you sort the data by different criteria. For example, if you set it to elapsed time by module, you can sort the elapsed time data for each module. That's all for Top End analysis function. The elapsed time analysis screen provides two functions. Firstly, the summary trend provides a function that allows you to freely perform top-down analysis of 6 main categories for a given date. For example, you can view performance history for a particular date, which is grouped firstly by schema. After grouping by the first criterion, you can use the second criterion. For example, after selecting module, you can view execution history of modules performed by a schema called SOE. You can also do a top-down analysis of the SQL performed in the first new order. Let's see performance history for another module. So, you can go on to do top-down analysis in a variety of perspectives. And as you can see here, weight of important indicators, the actual performance information, and the colored bar that you see at the top shows the ratio of Oracle's weight class and CPU usage time. For example, the first SQL appears to have done a lot of user I/O waiting. And you can tell that most of the SQL that you see here have more CPU usage time than CPU waiting time. And by right-clicking, you can jump to full SQL test or long-term trend as seen earlier. You can also click SQL details to view a 24-hour performance history of the SQL. A variety of information is provided. The elapsed time trend tab shows execution count per plan hash, as well as average elapsed time and average CPU time information. The I/O trend tab shows logical reads and the physical read trends. Wait time trend shows wait time information per Oracle weight class. The middle section shows the same data as the tabs shown above, except that it is a 10-minute summary. The right side shows the overall performance stats per plan hash value, with the middle section showing the SQL information, plan information, and bind information. If you wish to analyze a specific area, just drag it. Select the period by dragging and click OK to view performance history for the selected hour. Secondly, the SQL elapsed time scatter provides the same function as the SQL elapsed time frame which we saw in real-time monitoring. For example, let's try and extract all SQLs performed today, which lasted 3 seconds or longer in elapsed time. You can see the distribution of individual SQLs that lasted 3 seconds or longer in elapsed time. Right-clicking on the grid at the bottom gives you access to a variety of linked menus. Please note that each dot contains unique SID information, so it can be linked to session detail. Let's try it out. Then you can view the session list details. Using the session detail, you can view session performance history in seconds. Similarly, you can analyze a select area by dragging it. Each time you click in this way, the associate dots animate, letting you identify its position easily. We talked a little about the long-term analysis earlier. Top analysis provides analysis data in 4 perspectives: top schema, top program, top module, and top SQL. Let's try and retrieve 5 top modules. Then, you can view performance history of the top 5 modules for the last 1 month. As you can see, weight of each module and their actual workload. And at the bottom, you can see average CPU time, average elapsed time, and execution count for each module. There is one more tab next to Total tab. This automatically shows data for the date with the highest workload. Workload was highest on January 23rd. Here, you can see a 10-minute summary and workload details of the module called New Order, which worked the most. And clicking a particular date creates one more tab. This tab lets you view daily trends. A linked menu is also provided. Selecting a date at the bottom of the Total tab takes you to top end. After selecting a Date tab, if you wish to analyze a specific hour, you can drag it like this to access performance trends. We will talk more about performance trends when we get to trend analysis. And as seen earlier, OneSQL lets you view performance history by date for one particular SQL. Let's try and enter OneSQL ID. Here, you can view performance statistics by date for one particular SQL ID. Let me tell you about the SQL Plan Analysis. When generating statistics information, DBAs always worry how generating statistics of a particular table might impact SQLs, that the SQL could get faster, but they could also degrade in performance. Therefore, there is a need to check daily history on how many changes the SQL plan went through, and whether the SQL actually became faster or degraded in performance. This screen here provides a function for you to check changes in the execution plan. For example, you can find out which items had 3-fold or more changes in elapsed time due to changes in the plan during the last 1 week. Red indicates the number of SQL that slowed down. Green indicates how many improved in performance. Clicking the bar for a specific date shows you the list of SQLs corresponding to that date. So here, red means bad and green means good. Let's try and set one particular SQL. This SQL has got faster. It took 2,000 seconds longer yesterday, but it takes 600 seconds today. Clicking the Plan Diff button highlights the changed parts. The UI on the plan side is not very easy to use at the moment, so we plan to make it easier to view changes in the next patch. And the Crop Analysis section allows you to view insert statements, update statements, delete statements, and select statements that are used for access a particular table. Select an instance on the menu. You can select multiple instances. For example, in the case of RAC, if a conflict occurs in a particular table at a particular time, you can extract SQL accessing that particular table at that particular time by node. Let's select just one for now. Select 1 week for period, select SOE for table owner, and select the customer table. By clicking the Retrieve button, you can view the correct metrics for customers during the last 1 week. These results show that select operation was performed the most on January 23rd, as indicated in color. By moving it this way, you can adjust the gradation. By clicking January 23rd, you can view hourly performance history by date. You can see that select was performed quite a lot all throughout the 24-hour period. By clicking a particular hour period, you can see the SQLs that accessed the customer table during that hour. It's the same for update. By clicking a particular area, you can view the SQL that updated the table during the hour.